Okay, so hello everyone, and thank you for inviting me to join the lecture. And I will say I'm gonna open and close the file in a second. Sorry, I lost the rhino. All right, I'm back. So at the beginning, let me have a brief introduction about myself. And my name is YangSong, so you can call me Yang. I got the master degree from the architecture school in Bartlett, UCL, and in the cluster research cluster 9 for augmented reality development. And since then, I started to do the cross-disciplinary research related to architecture design and also augmented reality technology. So for now, I'm the augmented reality technical assistant in the FabHub digital design fabrication company in London. And also I'm a practice-based research PhD student from the Carver University of Liverpool. So I continue the research direction and try to add the robotic and also data in my research. Try to explore the relation and between human, robot, and also data and their mutual relationships. So I think today's tutorial is highly related to my research and my work. Hope you can enjoy. So today's task, I'm gonna have a brief introduction about the Fologram plugin and also how can we connect the device from your HoloLens and also from your mobile phone. And the third task of today is the basic operation in Fologram. And also I'm gonna introduce like how can we align the virtual and physical world together. The last is the interactive button I'm going to introduce. So let's start with the Fologram introduction. So the Fologram is a platform for designing and also making the mixed reality. So it can achieve the mixed reality live stream and also save model to preview from your smartphone, tablet, and headset, including HoloLens first generation, second generation, and iOS devices and Android devices. So on your laptop client, the Fologram is installed in Rhino and also Grasshopper for the live stream and the interaction inputs. And on your mobile device client, the Fologram app provides AR interface for you to modify, and also you can play with the holograms. And so this is like a basic introduction video about what can Fologram do.
Fologram connects mixed reality devices to CAD modeling software. You can use Fologram to build and share your own interactive experiences, all within the tools that you'd normally use.
Fologram is going to bring us into a new era of design.
When you realise that what you're looking at is the thing that you're about to make, it almost becomes immediately intuitive.
It's totally life-changing.
So if you go from a bloody sketch and then with your 3D modelling on the computer and then to produce this, it's just mind-boggling.
It's been exciting to see people realise ideas and designs which they thought would otherwise be impossible in minutes with Fologram.
Drawings have always been seen as integral to the profession of architecture, but while they're incredibly good at describing two-dimensional geometries, they aren't good at describing non-planar geometries. Some of the models that we've been creating simply would not be possible to build in any other means.
Yeah, so this is the website of Fologram. You can check online about what kind of project they have done, and also they have like very basic tutorial for the beginners. So this is the device connection. So I'm gonna show you in Rhino. If you install the Fologram successfully, you can see a panel here, which is called Fologram. If you cannot see that panel, just have Fologram here to call it up. So here we have like two functions. One is Fologram, the other is create QR code. And on your right-hand side, you can see a Fologram logo here. This is the QR code for you to scan. I will explain that later. So first, I'm gonna show you some basic operations for this plugin. So you can find your Fologram plugin in Grasshopper by clicking here to launch the Grasshopper, and there will be a Fologram panel. In that Fologram panel, there are like 4 sections, which are the flow, sync, track, and also utilities. So they have like different functions for you to interact with, and also track the device and track your hand gestures, track markers, taps, and track states. So the first basic operation I'm going to show you is the thinking objects. I will do that now. In the share file, you can see this is the file that I create and share to you. So I have already done all the Grasshopper visual coding. So you can select them and click to enable them. Try to see what happens. And you can also follow me step by step, or just follow my logic and check my file later. So the first is thinking object. So this means like when you create geometry in Rhino or in Grasshopper, the Fologram can help you to show that in AR. So to achieve this, we're gonna use a mesh sphere first. So in the Grasshopper, we're gonna create a mesh sphere. We can set the radius to maybe like 20. And go to Fologram. Choose this one called sync object. Connect the mesh to the sync object. So after that, this sphere gonna show in your AI environment. And one thing you have to try to explore is that when you right-click on the sync object component, there will be several lists for you to play with. The first is movable, clickable, and grabbable, which means that if you click the movable, it gives you opportunity to move the ball in the AI environment. And also similar like clickable, you can click, grabbable, you can grab that from the HoloLens. And the color means that you can choose a color according to your need. And also you can change the transparency. And for here, you can select the texture. For example, if I want a texture like that, it's going to appear on the sphere. If you don't want that texture, just tap that again, press cancel, and it will back to the pure solid color. And also you can change your specular and also gloss. So I'm gonna show you how can I launch that from my mobile device. Let me have a yes. So after you download your Fologram app, you can press that and press the rhino first to generate a QR code for Fologram and scan that QR code. So now you can see my device has already connected to my Rhino, and this is my mobile app. It is real-time scanning the environment. So I can tap the ball here on my table. Because I set the ball to movable, so now you can use your finger to move the ball wherever you want. And also you can right-click here to change the color. It will show in real time. If you want to play more fancy things, you can choose a component here called sync parameters. Select the radius with the logo on. So now you can click the left-hand side corner of your app. There will be a slider. So you can adjust that to see I can have a real-time modification about my ball. Yeah, so this is the first example, very simple, like how you can sync your object to your AI environment. And I'm gonna show you something else. The second thing, basic operation, is about the thinking parameters. So there are totally 4 types of parameters that support the Fologram to thinking in AI environment. So they are the first one, number sliders, which I just showed. And the second one is button. The third one is Boolean toggle. The last one is value list. So these are 4 types of interactive sliders that you can play with in Fologram. So I can show you some example about the button or something. Okay, like that one. So similarly, we can create a mesh sphere. We can change the radius to maybe 60. And play with the UV line. So let's say I'm gonna set the U to 20, maybe V to 20 as well. So after we got the geometry, we can get the mesh edge. So we're gonna use the Fologram sync object to show the sphere in white, and I'm gonna show the edge in red, in pink. All right. So I can change the transparency into like half, and use the sync parameters to play the radius U, V into the Fologram app. So now you can see this is the ball I just set. And after you click the menu, you can play with the radius, play with the UV. So it like gives you an opportunity for you to have some immersive modification or immersive design according to your grasshopper file or also your Rhino file. So the next one I'm gonna show is like the button. Okay, the Boolean toggle. So in this script, it means like I create a sphere now, and I use the call pattern functions to hide or show my sphere. So you can see like in the random file, I can turn on or turn off. So if I launch my AR environment, you can see I can turn off or turn it on. I can also select this toggle into the interactive parameter, interactive toggle. So I can use the Fologram menu to turn it on or turn it off. So this function gives you an opportunity, like if you have multiple things to show, you can use this kind of function to choose which one you want to show or which one you don't. So it can gives you an opportunity like for assembly something or fabrication something, like showing the things in layers or showing the things in their orders. And the third interactive parameter is the button. So in this file, I use a button first and use the data recorder and a mass addition, which means that every time when I press the button, it will record and add 1 + 1 to the radius. So I can show you that in Rhino. When I press that, you can see a small sphere, which is the radius for 1. And I press that, the sphere goes up. So this is also another interactive method for you to play with your model. If you want to check in the AI environment, on the left-hand side, you can activate your menu, and here is the button. Just press that, and your sphere will grow in your AI environment. And the last thing of the interactive menu I'm going to show you is the value list. So for the value list, it is in the input value list. You can double click that to edit that which is the input and which is the sliders. So for me, I'm gonna set 1 is 1 and 2 equals to 2. Maybe we can set 30 equals to 30 and 40 equals to 40. So in our sliders, we have 1, 2, 30, and 40. I want to do the populate 2D, so we can set the number here. As you can check, if I set 1 to the numbers, it means I just got 1 point here. And I can choose like 2, it will be 2 points, 30 or 40. We can use that point as the base for the sphere. So we can create the sphere here. But they are too crowded. So I can set a rectangle. You can right click the rectangle, set one rectangle to define the gap between them. Still a lot. Yeah. So like you can choose 1 or 2 or 3 or 40, any numbers you want. Just double click here to set the number you want. So I think this will also give you an opportunity in the future for you to design some things. Yeah, you can think about that in your own workflow. So these are 4 types of interactive input or sliders that we can achieve in Fologram. The number slider, the button, Boolean toggle, and also the value list. So just keep them in mind. These are the things that you can play with in the AI environment, which related to your Grasshopper file. And the next I want to show is the think text. So if you have like many components for you to assemble it is necessary for you to show the order index. So this function gives you an opportunity to show the index of each component. So actually, you know the assembly order. For example, I'm gonna show like that one. In the sync text component, it asks for a text here, so we can double click and enter some words that we want to show, maybe like SCI-Arc. And the P means that the reference point. So we can actually create a point here. Maybe we can use the sphere as you set the sphere radius. And I'm gonna sync the sphere. Also get the mesh. So I will get the central point of the mesh to be the reference point for the text. So for now, you can see the text is related to my sphere. So for the S input means the size of the text. You can change that to whatever you want, maybe like 50 or something. And let's check that in the AI environment. So for now, you can see the text is attaching with my sphere. If I choose my sphere to be movable, so anytime when I move my sphere, my text will follow me. So you can use this function to connect your index with your geometry. And like for that one, if you have a group of geometry, I can show you how to show the index of each geometry. So for example, we have the sphere here, and we choose a rectangular array, which means that we can get a group of sphere. And I'm gonna change the rectangle size to make them a little bit clearly. So now we have a group of rectangle, a group of sphere. So if you want to choose the sphere in the AI environment, you must convert them into the Fologram first. So to do that, choose the same object to convert your geometry into the AR geometry. And right-click here, choose clickable. And use another function in the track, which is called track tabs. So this component actually track where you tap in the AI environment. So you're gonna tell your component, I want to tap one of this geometry. And for the D input, you need the connected devices, which means the Fologram gonna know what kind of device you are connecting now. So the input, the output of the I means the index of these balls. So I'm gonna go do a list item. So it is in the list item. The list is my group of balls, and this is the index from the AI environment. And I'm gonna find the middle point of the sphere, set that middle point as the reference point for my text. So I'm gonna use the sync text, connect the C to the point. The T means the index that I wanna show. So I'm gonna connect the I to T and set the I's to 50. So in this file means that when I press one ball, it will show the index of that ball on the sphere. So I'm gonna show you in the AI environment. So for now, you can see a group of sphere. So I'm gonna tap this one, so you can see the index is 2. I'm gonna change the color; they are similar. So I will change the color of the ball into blue. Now you can see when you tap the sphere, it will show you the index of the related sphere. Yeah, they are kind of interesting. So you can play with the grasshopper file that I share with you for this kind of basic operations. And one more basic operation is the tracking device. So it will track your mobile phone and also your HoloLens. I will show you how that works. So basically, you need the connected device first, and then here is a track device. You can connect them together. So you can see from my grasshopper file, actually my mobile phone is in the in the digital world. So in the real time, I'm moving my mobile phone. It is like a real time stream. So from the tracking device, we can get several outputs. The first is the point, which means the middle point of the device. And the second one you can get is the mesh. So actually you can get your device mesh. And the last thing you're gonna get is the check is the plane. So actually, you can get your mobile device playing when you are moving that or something. So it gives you like an interactive with your devices. You can also try that on your HoloLens because I don't have HoloLens now with me, so I can only show you from my mobile device. So these are some very basic things from the hologram. So next I'm gonna show you is the virtual and reality alignment. So after you create your geometry or your process in AR, how can you align them with your physical world? So in the Fologram, they have a function. They have a function in Rhino. When you click the Fologram panel, you can see create QR. So press that. It asks you to select a reference point and ask you for the direction. So the red means the X direction and the green means the Y direction. After you select the direction and tell them your reference point, it will generate a QR code for you. So after you do that, it asking for your paper size. So it supports like customized paper size, or normally I just choose the A4 size, and also a folder for you to save your QR code. For example, I'm gonna save my QR code to this folder, and I press enter. So now the QR code is generated for me. And in your mobile device, you can open the Fologram, press the right corner button. There will be a snap function. Select the snap function. And that location will be recorded in AI environments. So this is the way for you to align some digital design with the physical environment. Like if you want to place your design on some specific point on the ground or on the floor, you can print this kind of QR code for the program to read and place the holographic design. So I think these are the very basic functions for you to know as a beginner for the Fologram. So if you want to know more about the Fologram operations, you can check the link here. I'm gonna send the link into our group chat.
Can you also send it to me as email or text?
Yeah, I will send you after the tutorial. So in this link, you can check like every single specific input description and also output description of the Fologram in Grasshopper. And also in this website, you can also check like their workshops, their fabrication outcomes, and like their projects, which all done by the Fologram team. So next thing I'm gonna show you is like a basic function of their project. So they create some interactive button not related with the Fologram user interface. So they will just appear in the AI environment. So you don't need to like access the menu from your app. You can just do it in your design or assembly environment. So this project is called it's called the woven steel structures. And yeah. So this project happens in the Kadria conference in Tsinghua University in 2018. And it is a workshop instructed by the Fologram team. So the end of the result is just a simple steel structures, but the implication is much more larger than that. So since the building was constructed entirely by eye, the project proves that augmented reality actually can fulfill one of the functions that's allowing uses of technology to complete the complex mechanical engineering task without any advanced knowledge or advanced technologies. So they can assemble that without a complicated blueprint. This is the video about how they achieve the metal bending and also the assembly process in the Fologram app. Yeah, so you can actually see like how complex the geometry shape they are. So like in the traditional fabrication process, we cannot achieve that very quickly. But for this project, with the help of augmented reality, they just finished the metal bending and also assembly the whole structures in 3 days. So it's kind of a great experiment that AR can help us to reduce the complex tasks from the previous or traditional workflows. So I'm gonna show you some file about how we can generate the shape like that and how we can bend each rebar or each metal rod, and how we can create the interactive buttons. So this is the file that I share with you. And in the top area, I'm gonna enable all of them. So this is script that help us to generate the shape. For example, for their like very crazy shape, you can change the parameter here to maybe up to like 80 or 90. And double click here to generate the shape. Maybe it is too much. Let's change it to 60. So this shape is generated by the customized script C# and also with some gravity simulations in the plugin in Kangaroo. So this is like how they generate the shape. Because today we just gonna introduce about the AR settings and also the interactive buttons. So I won't explain all of this. They are too much for you. So you can play with my grasshopper file after today's tutorial. And if you have any questions, you can ask me or email me. I'm gonna just use 40 for example. So this is how we get the shape of that crazy geometry. And here you can get like which component you want to fabricate. So let's preview, like we can preview here. This is the second one that I want to do. You can also choose like 0 or 2, 1, 2, 3, 4. Like select your fabrication geometry. I'm gonna select the number 2. So after this step, the script here means I'm gonna flatten all the metal rod into the on the floor. So I'm gonna show you here. Like it asks me something, right? Yeah, so for now you can see these are all the components or all the metal rod in the part that I select in the part 2. In this part. So we actually have 11 components. So these are the 11 components. And the file here is a metal bending file. So I can show you how to bend. It will give you a bending radius, which is like similar to that, similar to that manual bending machine. So this is the bending radius, and the color in red means the current shape, and the color in green means the target shape. So you just need to like stand here to bend your metal rod to fix the green target. And the logic of bending is like defining 2 points from this arc and find the middle point as the bending reference, and orient all the things to the fabrication bending center. So actually for here, you can choose which part you want to bend, because now we have like 11 parts. We can bend start from index 0 or 1, 2, 3, 4, 5, 6 till 11. So it will gives you the specific length of the metal rod you need, and also in each part you can check each bend. So in this ladder, you can bend from the first bend, second, third, fourth, which will help you to make the similar shape as that. So after you bend all of them together, you can use the function that I just taught you before, that I just introduced to you before, like the syntax, to number them for you to assemble it. So how can we create like interactive button here? As you see in their example, they have like a button which can help you to change the index and also to change the order, bending orders. So the script here, you don't need to understand, you can just follow. Like here, I create 2 pairs of buttons. The logic of that is to first create a polygon and make it as a surface and extrude them as a box. And we need to bridge the gaps of the caps. And also we can move that, mirror that into 2 pairs of buttons. For this component, you can actually move the location of your button. And here, these are the important things that we need to do today. So how can we achieve the interactive of these 4 buttons? We need to get the index of them. So the first thing we need to do is called list item. So we will connect the G to the list, and we zoom in, click this one to get the number 0, 1, 2, 3, which represent 0, 1, 2, 3 of this 4 button. And we can find the middle point of this button. And we move this middle point a little bit upper. We use a function called move. Move this geometry to z-axis. You can select the vector. Here is a vector, choose the z-axis. We're gonna set the distance to 250. So actually for now, you can see your reference point is here. Same way, we're gonna move this part a little bit upper. So they are our 2 reference points. We're gonna write down some text here for you to remember which pair is operating the parts and which pair is operating for the process. So we can input some text like part. And we use a function in the set. Yes, it's called text join. So we're gonna join the part first, and we're gonna join the index. The index is here. Press Shift to join them together. And we choose Fologram, think text. And we choose this one as the reference point. So now you can see the part 0 is here, which means these two buttons are operating with the parts. Similarly, we can do the same things. Let's copy and paste that. We change the name as end. And also use the text join component, connect the band with the bending index. Press Shift. And use a sync component to show the band. And use this point as a reference point. So now you can see that clearly in the AR environment, we are operating part 0 and then 3. And the next thing is how can we activate that into our AR environment? The first, we need to convert this geometry into the AR geometry, like into the Fologram geometry. So we use the sync object, connect this geometry to the object, right-click, choose clickable, which means that you can click them in the AI environment. And we're gonna use a function called track tap. Connect this AR geometry to the G and choose here connected device. Connect the connected device to the D. After that, we need a state gate, which means that if they have the index as 1, they will go to this pathway. If they have the index for 2, they will go the second pathway. So now we have like 4 index. I'm gonna create 4 pathway. So for here, you can change the name to 1 to 0 because the grasshopper starts from 0. So if you have 4 components, it means 0, 1, 2, 3. So I'm gonna name it as 0, 1, 2, and 3. Connect that to the index. So next, we're gonna use a component called get global value. In the global value, we will right-click, change the name as part. Because when we want to press this button, we want the path index plus 1. So we're gonna get the current path index and use a math to plus 1. So it means that the computer will get your current part index and then plus 1 when you click this button. So after that, we're gonna set the global value. So this component means you will let the computer know your current part index will be the previous plus 1. So this is the operation for this button. we have to remember, like every time when we change a new part, the band will start from index 1 or index 1, because we don't want it to be already banned. So we're gonna set 1 as index for our band. So we right click here, rename as band. So this is the script for our first pass, which means our first button. And we will create the second button. The second button will be a little bit easier because we only change the band index. We don't change the part index. So for that, we're gonna use the get the current band index, change the name to band, and use +1. And set this current index to AR. So this will be our second script for the second button. Similarly, we can copy and paste them. For the second and the third. The only difference is that we need to change the plus into subscription. So a subscription. So we connect the A here and connect 1 here. We're gonna replace that one. Right click, add to group. So we want the current index -1. And we delete that, add to group. So now we finish the button part. Because here we use the grasshopper sliders, it is not the Fologram sliders. So we need to create get global value. One is for the part, one is for the band. And remember to right click here, choose the dynamic update. Connect this part to replace the previous one. Connect the band to replace the previous one. So now we have already set up all the things in AR. Let me show you how that works in AR. Second, I need to restart this software. So now you can actually see two buttons and the holographic things. So I'm gonna press. So press when you press the part, it is actually changing the part that you are selected, and you can press bend. Yeah, so you can play with the file that I shared to you. Just enable all of this and try to try this kind of experiments in AI environment. So I think that's all for today's tutorial. And if you are more interested in their research about the metal bending things, you can search about this paper, which they published in Arcadia in 2018, which is called Making in Mixed Reality. Thank you.